So the first thing I'm going to do is I will generate a threat into our environment. So we're going to run a crypto miner. And the best way to do this is through the newly created Sysdig threat generator. Why we're using this deployment is, again, it's a consolidated deployment that all SEs can make use of. We use a single image, which is this Docker bad boy art latest. Within that image, what it's going to be responsible for is running the exemrig binary. And as well as that, we are going to do something which you shouldn't be doing, which is giving the escalator permissions via security context to privilege set to true. Now, once you've deployed this deployment, like in our case, if I say kubectl apply-f crypto miner, you should see it's already created, it's already running inside our environment, so it's unchanged. Now, going back into the console, what you'll notice is that a series of things have happened within the Kubernetes environment. So from here, we can see that namespace has been created. There's a deployment created. In this deployment, we can see it's the threat gen as per the deployment name. Again, you can call this out from the deployment file. So yeah, we've created the threat generator. What's important from a CDR perspective is that we can say, for instance, at a cloud native user level, we can see what was the Kubernetes user that actually created this resource, which was the Kubernetes admin. Nothing malicious about this. Again, it's a blue alert, so it's nothing for us to worry about. Where we start worrying is when we start seeing these kind of medium quality alerts, things like privilege pod created. Now, there are a bunch of different privilege pods I created in my environment, but again, you can see a running trend here. Threat gen is the pod now that's running as the privileged pod. So that's what we're going to focus on throughout this demo. What you can then show a customer is, again, the MITRE ATT&CK framework that ties into it. So for instance, this is a container administrative command. So they know this has been given admin level privileges. And with that, they can go and proceed to do other things within that pod. Now, the first thing we'll notice when the privilege pod was created is within ThreatGen, again, you can see it's the same container over and over again, is that they're attempting to write the exemrig binary. So you can see version 6.18 within the temp directory. Now, there's not a whole lot to say other than it was a successful write activity. You can see that they achieved this as the root user. And before that, they had this tarball that they opened up and they moved to temp. So from that, we get process command line. We can see that they ran bash wget to pull the binary from this GitHub hosted location. And from there, they're performing a bunch of other actions afterwards. All you need to focus on from the CDR perspective is we're looking at how a user goes about getting a crypto miner into an environment and how they detect it in a cloud native environment. So at this moment, they've just written the binary. That's all they've done. Now, we noticed the root action there taken a second ago. So being able to alert on, for instance, set user ID or set group user ID to like essentially performing chmod to change permissions to root is really imperative. So we can see that they have been given root group access. So now they can run as root admin, or root user, I should say. So we can see again, it's exemrig. There's not a different file in this case that's doing this. It is consistently exemrig that's running as root. So these are what we would call the indicators of compromise that lead up to the crypto mining incident. You know, we don't really want them being able to give themselves elevated permissions. They shouldn't be running as privileged pod, for instance. We want to prevent that activity from happening. But also, like, just unusual behaviors like writing into temp. Is there any good reason why you would write into temp at runtime? So, you know, being able to detect these are all critical activities. I'm not adding more value by calling out individual metadata within the alert. It's just important to know that these are all individual indicators of compromise that lead to the incident. Now, we know that the binary is the exemrig binary that we see here, exemrig 6.18. From a demo perspective, you'd probably want to go into rules and actually call out the rules. So in this case, it's the malicious binary detected. So we go in here, you can type in binary, for instance, and then under malicious binary detected, you can actually show them, for instance, what are those in malicious binaries? You know, you have a macro, well, in this case, a list of all those malicious binaries. So there's things like exemrig, but it's not just exemrig. You might have, for instance, Astro Miner or NB Miner. These are all the different binary names that could otherwise be associated with a crypto mining incident. Again, why it's important to call these the indicators of compromise is that a new name might come along. It's not necessarily added to this list. What you want to demonstrate to the customer is that from our CDR perspective, we have a threat research team that are updating this list. It's managed policy. So again, this is being updated for you. What you can show them is that, again, it's enabled, it's being updated, it's managed, but these are categorized as indicators of compromise or indicators of malware activity. So going back to the UI, if I just paste in the link there, you can see we've shown that the privilege pod was created, the malicious file name written, they gave themselves estimated privileges as a root user in the temp directory, and they have created the exim binary. Where it starts getting interesting is things like, what are the actual mining activities? So things like detecting connections going out to mining pools. This is going to be fairly consistent for the most part. So you're going to have to talk to, for instance, similar ports over similar IPs associated with these mining pools. There are ways that they can evade detection, and that's why we're trying to tie it into this historical event, this Tesla crypto mining incident, where they try to hide those connections behind, for instance, a CDN, content delivery network like Cloudflare, so that we wouldn't actually see the connections going to one of these ports or IPs that, would normally indicate connections going out to a mining pool. So it could be going out to a server hidden behind a CDN. So it's important to call these indicators of compromise, because although this would heavily suggest that mining is actually going on, and it most probably is, there are ways that we can't just rely totally on the network connection. We need additional capabilities to protect ourselves. And that's where we end on indicators of compromise. We need to talk about, for instance, next gen type protection. And I'll start with drift detection. So drift detection works in two ways. You can enable this policy. It's not like in the Falco rule set, it's kind of external to Falco in the sense that it's dynamic, it's a dynamic deny list. So going into the alerts, you can see that you can detect or prevent. So you have the option to toggle on this feature to prevent. Now, in our case, I've chosen to prevent each time. So if you click into the rule, you can actually see, look, the drift was prevented. What this ensures is if a user tries to write to the temp directory, a bit like what they did earlier to install the exim binary, that action would outright be prevented. They wouldn't be able to proceed to do crypto jacking on workloads running at runtime. That would protect us most of the time, or at all times in case of trying to compromise existing workloads. However, again, the threat actor might not try to be compromising an existing running workload. They may have got around to creating a new workload with the binaries in it, so we didn't detect that drift. So again, as useful as drift detection is, and we strongly recommend using it, there are ways that they may evade detection, like already creating the workload with the binary packaged in there, or if we didn't have drift prevention enabled, we had simply drift detection. So we could detect what's going on in runtime, but we didn't actually prevent that drift from occurring. Like, for instance, in test lab environments where actually some drift may happen, where someone wants to install some binaries for testing tools. So with that, we want to have one last layer of protection from a runtime perspective, where we can say detect based on machine learning. So that's where we have crypto mining detection, and it's why we're talking about crypto mining throughout this demonstration. Is you can go to the crypto mining detection rule. Going into, you can, unlike all the other fixed rules that are based on condition sets, like if it connects to this port and matching IP, then trigger an alert, or if it finds this binary name, again trigger an alert. So in this case, we have a machine learning algorithm running, and it's designed specifically at this moment in time for crypto mining. So going into the actual triggered alerts, it tells you to 96% confidence, irrespective of those fixed rules you had earlier, irrespective of whether the connection's going out to a server behind a CDN, or connections are encrypted, or whatever it is that they normally use to evade detection, like from a traditional EDR solution that's focused heavily on if there's a spike in network activity to dictate if it's mining or DDoS. In this case, we actually say, look, our algorithm detected it was eximrig was the command run. Here is the location in the temp directory. And yeah, we're pretty confident with all this extra additional metadata that this is in fact crypto mining. It's a high severity alert. And from there, you can decide to remove the miner. But because you have the additional cloud native context, you can say, okay, it was this deployment, this container running in this network namespace. We have all of this context within the Sans crypto cluster name, so we know which environment it was actually run in. Now, CDR doesn't end with just what goes on at runtime. Naturally, we're focused on what happens at the cloud environment. So you might want to look at, for instance, escalation of permissions that might have occurred on the cloud tenancy level. From AWS or Google Cloud or Azure, whatever the cloud provider it is that they're using, naturally this part of the demo is going to be tailored somewhat towards that. So for instance, we can see that the cloud environment was created, the user could log in, but they didn't necessarily use multi-factor authentication as a way of getting into the environment. So we want to look at what is untrusted behavior. So things like using MFA is a great starting point. It means that even if the user has access to passwords from stolen credentials, they still need to use another multi-factor authentication method like an authenticator app to actually get access to the cloud environment. So in this case, we can see the user's logged into Google Cloud, I assume, was the environment, again, tying into the MITRE attack tactics, like the initial access to the environment is integral to see where that is in the attack chain. But also from an identity and access, we can say, yes, we are CDR, we're not a CNAP, well, we're more than CNAP. So we can actually also give CNAP type functionality in the sense of we can recommend least privilege policy. So you can see in the case of Carlos, in his case, he has access to a bunch of different features of the cloud environment like AWS, but they don't actually utilize all those features. So the user is actually using, for instance, EC2, but they have full access, and like they were given 711 permissions, but they use 666 of those. Now that's maybe not the best example, but there are certainly features that the user is not making use of. So like 12,931 unused permissions. In that case, you can generate a user-specific IAM policy to actually implement least privilege. So rather than doing all the painful manual work, it recommends a policy that enforces least privilege. And then from a policy perspective, it's important to say we collect via Falco audit activity from the different sources, whether it be runtime we talked about a while ago, so syscalls and the Kubernetes audit log, but also from the cloud audit logs. So if we go to policy and we go to rules and the rules library, you can obviously filter down to the rule source, so things like AWS CloudTrail. From here, I could just click on, I don't know, AWS, and then see everything that has the AWS tag, as well as the obviously filtered context of CloudTrail. Now, what we talked about earlier about least privilege, for instance, we showed an alert triggered for a user logging into the cloud provider that could be compromised. They may have got access they shouldn't have, and they logged in without MFA. But also we can define, for instance, untrusted. So you could say, for instance, console login from an untrusted IP. So this is kind of implying we take the cloud log source, which is CloudTrail, but we start adding our own touch on it. We can define what are trusted IPs for accessing the cloud console, like what are expected users in a way that should be logging in. Because again, it won't be based on the user, because if the user is compromised, we want to say from what IP is trusted. So if we go into the actual Falco rule, you can go into the macro for trusted IP addresses, and from here you can define what those items are. That way, anyone who had access to those credentials, who were able to log in without MFA, and for instance had all of that escalated permissions that they shouldn't have had to access different services within a cloud provider, you can actually define what are those trusted IPs to alert on, again, potential signs of compromise that may have led to the crypto mining incident. And with that, that is our end-to-end story that covers, runtime security, including the cloud auditing, and then next-gen features like drift prevention and crypto mining detections to prevent compromise at the container workload level and the host level. Hope that's useful.